Okay, class, this is the podcast for the atomic structure test version A. Let me just run through this with you and see how well we can do this. So what element probably has properties similar to fluorine? Okay, so if you recall on the periodic table, I pull up a pen here. So in the periodic table you have a square table basically, and you have these various vertical columns like this. You can count on the elements in the vertical columns having the same numbers of valence electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so you got them going this way too, like this. All right, so for example, lithium, sodium, potassium, these all have one valence electron, and they are one chemical family. 2 valence electrons would be, say, beryllium, magnesium, 3 valence electrons. Now we have to skip over to boron, and then aluminum, and then 4 valence electrons, carbon, and silicon, etc. 5 valence electrons would be nitrogen and phosphorus, 6 valence electrons, oxygen, sulfur. 7 valence electrons would be fluorine, chlorine, and then 8 valence electrons, things like neon, argon, and so forth. Okay, so you can find the elements with similar chemical properties are the ones that are in the same vertical column. So fluorine here is right here in the same vertical column as chlorine and bromine and so on. So the answer here is chlorine. It's very similar to fluorine. Okay, so then moving down, hold on a second, went too far. Okay, the next one here, particles that are not found in the nucleus of the atom. Okay, so the nucleus of the atom is where you find the protons and the neutrons. The electrons are out here flying around in these clouds. So you're not finding any electrons out there. Compared to an atom of carbon-12, now carbon-12 has 6 protons and it has 6 neutrons. That's why it's 12. You add these together. Carbon-13 has 6 protons also, but it has 7 neutrons. So you add these together, you get 13. That's the meaning of these numbers, 12 and 13. So obviously compared to carbon-12, carbon-13 has more neutrons. So where is that? Right here, D. Which pair of atoms, X is the symbol for the atom, are isotopes of the same element? So isotopes of the same element mean it has to have the same atomic number. And so these are the same elements. In fact, this would be carbon, since carbon has an atomic number of 6. The larger number is the mass number, but notice the mass number here is different. So this has 1 more neutron than this one. So this answer right here is the answer to the isotopes of the same element. Okay, so now first we have this picture here. Let me show you what this means. In the nucleus, it's showing 1 proton. So let's say this is the atomic number, the number of protons in the nucleus. The entire nucleus, let me draw it a little bigger here for you, it contains protons and neutrons, but the sum of the protons and neutrons is the mass number. So if I have 1 proton, I must have 0 neutrons. Since the mass number is only 1, 1 plus 0 is 1. This number tells me the balance between protons and electrons. So obviously I have 1 proton. Since this is 0, that means I actually have one electron. The 0 is because when you add these numbers together, you get 0. So that's what this number is the balance between the protons and the electrons. You'll see later how it could be 0, a positive number, or a negative number here. So what is false about this? It's the lightest element, and that's true. 1 proton is true. It does not have 1 neutron. So this is the false answer. So what is true about this isotope? Again, let's go through this and make sure you know what this picture means. It's helium, so it has 2 protons. This mass number here is the sum of the protons and neutrons, so this must have 1 neutron. This number is explaining the number of protons versus electrons. So it's showing I have 2 protons. The 0 here means I also have 2 electrons. So these are -2. You add these together, you get 0. That's what this number is, 0. So the positive charges added to the negative charges give you 0. So what is true is this isotope contains no electrons. No, actually it has 2 electrons. This isotope contains 3 protons. No, it contains 2 protons. 2 electrons, yes, that's the correct answer. So the answer must be C here. Okay, so what is this picture showing us? Again, we have a lithium here, which must have 3 protons. And because the mass number is 5, it must have 2 neutrons. So 3 protons and 2 neutrons add up to 5. This number means that between the protons, which I have 3 positives, and the electrons, since I have a positive one here, that means I must have only 2 electrons. Because when you add these numbers together, you get a +1. Okay, so that's what this is. This is when you add together the positives and negatives, you get, in this case, a positive. So what is true? This has a mass of 3. No, the mass is 5. This isotope contains 1 electron. No, it actually has 2. This isotope contains 1 proton. No, it contains 3. This isotope contains 3 protons. That's a true answer. Lithium has 3 protons. No, it doesn't have 3 neutrons. It only has 2 neutrons. Okay, number 8. What is true about this isotope shown in the element square? So obviously it's boron, meaning I must have 5 protons. I see 5 electrons here. So since these are positive charges, negative charges, and they add up to 0, this is a neutral atom here. I can't tell how many neutrons, but maybe that's not important. So what is true is it contains 10 neutrons. I don't know that. It contains 10 protons. No, it contains 5. It contains 3 valence electrons. Yes, it has actually 3 valence electrons. These electrons out in the outermost shell, that is the definition of a valence electron. So the answer is C. Here we notice we have 10 positive charges and 10 negative charges. So we're dealing with the neutral atom here. All the rest of them must be worse answers or false answers. So what is this picture showing? I have nitrogen, which has 7 protons. I must have 7 neutrons because when you add them together you get 14. And since I have -3 here, since I have positive numbers and my negative numbers add up to -3, I must have more negatives than I have positives. So I have 10 electrons, 7 neutrons, and 7 protons. So it does look like the answer must be C. Okay, so which response below is true? Well, this has 1 proton. It has 0 neutrons because the mass number is 1. As far as electrons are concerned, it has the same numbers of electrons as protons, so I must have 1 electron. They add up to 0. So this element above is going to be 101. 1 neutron, no, has no neutrons. 101, 2, 1 proton, 1 electron, and no neutrons. It looks like D. Okay, the next question here is about helium. Now here we have the atomic mass of helium. You can tell this is not a whole number. It's a decimal here. So this is the type of number you see on the periodic table. It's the average of all the isotopes of helium. It doesn't show a number, so I'm assuming it's neutral, the same number of protons as electrons. And I can tell because it's helium, it must have 2 protons. So this element is actually lighter than helium. This element has more protons than something else. Maybe down here, I got to pull up the rest of this question. I'm missing some part here. This element has more protons than neutrons. So it has roughly the same numbers of protons and neutrons. This element has 6 particles in it. No, it doesn't have 6 particles, probably in its nucleus. This element has more protons than, I can't tell what the right answer is because this question seems to be cut off. Oh, there it is, okay. So C, this element has equal numbers. That's the correct answer is C for that problem number 12. Okay, too bad that was cut off like that. Okay, which description is true for the following picture? Okay, well, I got to carefully count the protons here. 1, 2, 3, 4, 5, 6, 7, 8 protons. Okay, so that tells me we're talking oxygen, just like that, because it's 8 protons. 1, 2, 3, 4, 5, 6, 7, 8. So I'm talking 8 neutrons. 1, 2, 3, 4, 5, 6, 7, 8. In fact, we have 8 electrons. So this is a neutral atom. Its mass is 16. Its atomic number is 8. We're talking oxygen. And so this must be oxygen 16 because the sum of the protons and the neutrons is number 16. Okay, which statement is true for the following picture? 1, 2, 3, 4 protons. 4 protons is beryllium. I see the neutrons, 1, 2, 3, 4, 5. So I have 5 neutrons. Protons, I have 4, okay, for beryllium. So mass is 9. The mass is 9. Atomic number is 4. And it's a neutral atom because I see 4 electrons. So yeah, the answer is, this is beryllium, mass 9. So the answer is B. What is true about this picture? It doesn't have any information about the nucleus, but it does show me it has 1, 2, 3, 4, 5, 6 valence electrons in 3 rings. So 6 valence electrons is probably sulfur with a total of 16 electrons. I was going to go with the E, sulfur. So the mass number is the sum of the protons and neutrons. This has a mass number of 7. That's an easy question. This element shown in the picture above is, well, 7 protons. It's nitrogen. This answer here, you're told this is a neutral atom of lithium. So that means I have 3 protons. Now here we have the mass number down below. That's okay. That just means that I have 2 neutrons. You're just adding those together. And since this is a neutral atom, this must be 3 electrons, 3 positives and 3 negatives. Okay, so which of the choices below do you not know? The number of protons? No, we do. The number of particles in the nucleus? No, we have 5. Number of neutrons in the nucleus? No, we actually know there are 2. The number of electrons in the atom? No, we have 3. The number of electrons in the nucleus? There are no electrons in the nucleus, so this must be the false response. So what is a reasonable number of neutrons for this atom of aluminum? Well, with 13 protons, and if we round this to 27, say 27 minus 13, 14 neutrons is a fairly reasonable number since these have to add up to the 27. So I'm going to go with A. A is a good number of neutrons. Reasonable number. Let's see, number 10. This is definitely neon. There it is. The answer is this is neon. 15 protons. We're talking about phosphorus. And so maybe it's phosphorus 31. It must be phosphorus 31. That's the only phosphorus here. What is true about this picture? Let's see. So let's reconstruct this a little bit. Lithium has 3 protons. It doesn't say anything about the neutrons here. But lithium, if it's neutral, should have 2 rings of electrons like this, 2 in the first ring and 1 in the second ring. So this is clearly not a neutral atom. In fact, I can tell you right now this is a positive 1 atom because one of these electrons has gone away. So it's a positive ion with an overall charge of +1. It has to be. It can't be any easier than that. Okay, so in the above picture, look at the electrons here and explain in words what the pattern is for valence electrons as you go from left to right. Also notice in this first column, all of these have 1 valence electron. These have 2. These have 3, 4, 5, 6, 7, 8. So the answer is from left to right, you add 1 more valence electron. Basically, that's a pretty good answer right there, all the way up to 8. A beryllium-9 atom, okay, this is easy stuff. Beryllium, it's got 4 protons, make sure you indicate that. But if it's beryllium-9, that must mean it has neutrons. It has 5 neutrons for a total of 9. Show it with the electrical charge of neutral. So here I have to show 4 electrons. So the first shell gets 2, and the second shell is going to get 2. Okay, so then which ones are the valence electrons? The ones in the outer shell. This has 2 valence electrons. So there we go, that's beryllium-9. All right, so fill in the chart. All atoms are neutral. That means it has the same numbers of protons and electrons. That's what neutral means. So that helps us a lot. Atomic number for sodium is 11. That means it has 11 protons, and the number of electrons is 11 since it's neutral. Now the mass number turns out to be the number of protons, or in this case electrons too, plus the number of neutrons for a total of 23. Now 12 means that this must be magnesium. I can just tell because of the atomic number, meaning that these are also 12. Number of neutrons, you get that from the mass number minus the atomic number. I have 12 neutrons because 24 minus 12 is equal to 12. So what element is this? I can go by the protons. It's 9 protons, that's fluorine. Atomic number 9, and they're neutral with 9 electrons. Neutrons, well, it's 19 minus 9, we have 10 neutrons. So boron is atomic number 5, 5 protons, 5 electrons. This is 11 because when you add together the neutrons and the protons or electrons in a neutral atom, you get 11. Okay, so the number of electrons is neutral, so that means it's the same. And since it's 10, this must be neon. Number of neutrons, subtracting 10 and 20, I get 10 neutrons. So I have to fill in this part. A number of electrons, number of protons, and the atomic number are all 12. The mass number is going to be 12 plus 14, or 26. Since this is 12, this is also magnesium. And notice it's magnesium 26 versus 24, so they're both magnesium, but they're actually different isotopes of magnesium. Okay, so let's go to the next problem. All right, so what do I want you to do here? Modify the ring structure to show the correct number of electrons that would give oxygen in a full octet. 8 in the outer ring, so I have 6. What I wanted you to show me was 2 electrons need to be added to this outer ring. And when that happens, the oxygen will have a -2 charge. It'll have 8 protons but 10 electrons. So this is what will happen. The charge that results is -2. Now it has a full octet of 8 valence electrons. That's all you had to do there. Okay, now the thing to remember in this chart is that the protons and the electrons, these are not necessarily neutral. In fact, over here, this is explaining the chart. So like, for example, in the case of lithium, the first one, it tells me I have an ionic charge of +1. So since I have 3 protons, that's for sure. It doesn't say anything about neutrons, so we don't know the mass number of this. But we do know one thing. If it has 3 protons and the electrons, which are not given to me here, I'm trying to figure that out, I know that when I add these positive and negative numbers together, I end up with +1. That must mean I have 2 electrons, because that gives me a net of +1. +3 plus -2 is +1. So there's my answer. I have 2 electrons and 3 protons. So here I have proton 6, so this is carbon, and then 6 electrons means this is neutral, because you see these added together add up to 0. So protons I have 5, but I have a +3. That must mean I only have 2 electrons. Since these added together gives me +3. Protons 5, we're talking boron. Okay, so now I know the electrons. It's silicon. Silicon is 14. So that means I have 4 more electrons than protons. I must have a -4 charge. Neutral means I have the same numbers of protons and electrons. This has got to be helium with 2 electrons. So -1 here means that I have 1 proton and 2 electrons. Because you see 1 plus 2 minus, when you add those together, gives me 1 minus. Okay, so this is the one where you have to fill in the number of dots. Okay, well, if you look up in the periodic table on page 162 and 163, you'll notice that this is germanium, which is Ge, and it has atomic number of 32. And since we want to make this neutral, we need 32 total. It probably is going to say 2, 8, maybe 14, and that's going to have 4 valence electrons. Does that add up to 32? There's 18, 20. Am I missing something here? 2, 8, 4 rings, 14, 4. I could look this up to find out, but that's 24, 28. Somehow I'm not getting 32. So I'm going to have to check that one. I'll look it up. So my mistake here was this is not 14, it's 18. Now that makes sense. So I have a total of 32 here. We don't care about the mass number. So if I put 2 dots here, 8 dots here, 18 dots there, and in the outer shell, I make sure that I can see those valence electrons. 4 valence electrons is how many germanium have. They're just the ones in the outer shell. Those are the valence electrons. So you should be getting done with the test by now. Okay, let's see what was going on here. This atom wants to change its number of electrons to be neutral. Okay, so the words are down there, and here's the picture. Okay, here it is. So what is this atom going to do to change into a more stable position? Well, in the underlying layer, the second layer below here, see, it has 8 valence electrons. That will make an octet, 8 valence electrons. So it's like it has these 2 extra ones, which it's going to want to lose. So what we're dealing with here is calcium. When it loses its 2 electrons, it's going to be calcium 2+ ion. It's going to lose 2 negatives and result with a +2. And that will make it more stable. The calcium likes to be a +2 ion. And there's the end of the test. So thank you very much for watching.